Although in physics, you can also see often some optimization principle, and you can derive some laws that you know of from those principles. But in economics, often what we do is that you have something that we call utility function. Have you heard of that? How many of you sort of heard of? Good, so that I know. I probably heard about that much later than you, but it's good to know where we're at. So utility function is a function that describes how happy something makes you. So for instance, you can think of, this would be C as consumption, how many apples I buy, and it makes me somewhat happy. So maybe first, I'm happy that I eat some apples, and if I buy too many of them, it's too expensive, I waste too much money, and I cannot go to movies, or I cannot go on vacation. So this would be measure of happiness. We call it utility function, or how much utility it brings you. And often we are, the way we model how people behave is that we choose something that's good for us. If we don't quite know whether people consume too much or too little, we start with an assumption for good or bad reasons. Let's assume that people consume what is good for them. So we would say, okay, this will be the amounts that will be consumed. If prices of apples go up, maybe the happiness will look something like this, that for smaller consumption, we will already be quite unhappy, so then you will choose to consume less. So often models in economics have this form that you define something that we call utility function, and then you assume that people behave in a way that they choose Y, action. I'm calling it action in general because it can be consumption, level of investment, or anything. How much you want to work, if you want to employ someone, and so on. And you choose it to maximize this. In physics, often, or at least physicists that go to economics, use a different approach that is often called agent-based approach. Agent-based approach is that perhaps in your model, it can be a computer model, you have lots of different, we call it agents, it can be like lots of different people, and you specify with a fixed rule how they're behaving, how they behave. So for instance, you would say, people always consume half of what they earn, something like that, fixed rule. This is useful for some things that then it's easier to compute if you have population of people, the whole nation, how they would behave. But it has some disadvantages, and that is that we don't know what the fixed rules are. We don't know how people behave. So then the optimization makes sense in some cases. Like for instance, if taxes change or the law changes, or I don't know, Czech Republic enters European Union, suddenly the rules should change, right? But we don't know how. But if you assume, well, maybe people behave the way that's good for them, the optimization principle is good. Do you think it's perfect, the optimization principle? No? No, why not? You don't think we always behave the way that's perfect for us?
Yeah, I mean, we haven't evolved to be perfect beings.
We haven't, or we have, or?
We haven't.
We haven't, yeah, we haven't. So it's a good benchmark. So there are some reasons, either evolutionary reasons, or that we think about things that we try to achieve the optimum, but of course not always, right? So you get a test in physics, it also, not always it's fully correct, right? Sometimes you make mistakes and so on. And this is super important for economics or in general for social sciences, what types of mistakes we make and so on. This problem can take slightly more complicated form if you want to describe how your behavior depends on the situation or the environment. You can say there is some state X. State here doesn't mean a country, but like state in physics. Physics, it would be temperature or something. Here it can be current inflation, interest rates, or how wealthy you are. And then you choose Y to maximize this. Okay, So it can be, oh, there should be X here. So that's something what I said before, that your action, whatever it is, it can be consumption or something else, you know, your behavior depends on this state of nature. But just like your colleague said, we're not always, this will turn out to be somewhat related to rationality. We don't always make the correct decisions, whatever the correct means. That's also not clear. So what about this bet? Imagine that I would offer you, so this is Kč, is Czech crowns. 22 Czech crowns is $1. So I would offer you, let's make a bet. Let's say 50-50 bet. We would toss a coin. If you lose, you give me 1,000 Czech crowns. That's like $40 or $50. If you win, I give you 2,000 Czech crowns. For students, it can be quite a bit of money. So would you agree? How many of you would take the bet and play this game with me? Okay. How many of you wouldn't? Yeah, it's about half and half, I think. So I guess that those of you who would take a bet would do it because like the average, or we could call it expected payoff, is positive because you have a 50% chance of winning something that is double of what you can lose. On the other hand, you guys are students, all of you are smart. Eventually, you'll probably be rich if you care about money. If you don't and you care about more important things, you will not be rich, but it's completely fine. But right now, this is probably a lot of money for you. So losing 1,000 can be hurtful to you, and that's why you say no. We are different, we choose different things, that's fine. This is something that was observed in economics. So value, that can be also utility, like how much we value different changes. Gain is that way, loss is this way, and somehow we as people, we feel losses quite a bit. If you lose a bit, it often makes us much more unhappy than if we win a bit, how happy it makes us. So what if the bet or the offer from me was a bit different? It wouldn't be 1,000 minus versus 2,000 plus, but I would tell you, let's do it 100 times. So we would toss a coin 100 times, and then we would just add up these things. So now, how many of you would accept this bet? You're eager to win. How many of you would not accept? Much fewer. Those who changed the opinion and now would accept this, can any one of you tell me why? What is different now?
It's more likely that we can earn more from this. It's highly improbable that we are going to lose every 100 bets.
Yeah, very good. There is something like law of large numbers and so on, that it seems it would be unlikely that at least 2/3 of those you would lose and 1/3. Very good. So probability that you actually lose money is now less than 1%. Of course, you can lose quite a bit if there is many of those, but it's less than 1%. But if you start digging deeper, it's not clear whether it is consistent with the original, decision. And that is that if we draw something like something like our wealth and utility as a function of that, it is somewhat increasing. We're typically happier when we're wealthier. Then what would happen is, locally, this is something that has to be fairly linear, and that you accept package of bets. You should be, I'm not gonna explain details now, but you should be happy to accept even the one bet or the other way around. If it's not 1,000,000 crowns that is super important for you and determines your lifetime wealth. So we all behave this way, or actually many of us do. I might answer the same as you, but it is internally not quite consistent. So Often you might read in the news that economists talk about whether we as people behave rationally, something like smart and so on. So what does it mean exactly? So this has been studied quite a lot in economics, and because anytime you have an important problem at hand, it is good to approach it as a scientist. Or not always, but if you want to make as a mankind long-run progress, you approach it as a scientist. So it's good to define what you mean by rationality. So in economics, we mean this. It means that how we prefer different outcomes, let's say whether you like apple more than a pear or oranges, these preferences have to be somewhat stable. They have to be consistent. And I will tell you what I mean by that. If it satisfies these four, our behavior or our preferences or what we want, if it satisfies these four conditions, axioms, then we say we behave rationally. The first one is completeness. It just means that anytime you're given two objects, for instance, or two outcomes, you are able to decide which one is better for you or whether you like both of them the same. That it is apple and pear, that you can say, I like apple to pear, or the other way around. It's not that you would say apple and pear, and you say, oh, actually the other way around, and so on. So you have stable preferences. The other one is continuity. I'll skip that. It's just some technical condition. The third one is transitivity, and that is if you like apple more than pear and pear more than oranges, how should compare apple and oranges? Yeah. Yes, exactly. That there are like no cycles. If there were cycles, it would be weird. It would seem like, oh, there is something. We would call that not rational. And the fourth one, that's a trickier one, that is some sort of independence. And that is that if you like apple more than pears, and then I add something to it. I should not add beer here, right? You're underaged. I would say apple and $1, then you should like apple and $1 more than oranges and $1. If at the beginning you liked apple. And so there's some additivity, independence, and so on. So if our behavior satisfies these four basic principles, and it might seem to you that if you look at it, that of course any behavior has to satisfy these principles, then we are rational. And if we are rational, then you can actually, any behavior you can describe as maximization of this utility function. So those were results in economics that go 60, 70 years back. They were given Nobel Prizes for it. And of course, that simplifies research a lot, that suddenly we know how to model these things. Of course, then later on, it started turning out that we don't always behave this way. Just like that example with the bet, that the package that actually violated the fourth independence axiom. Another thing that I want to briefly show you that those axioms would, for instance, imply that, imagine this example. You're choosing between, maybe apples and pears are confusing, they're too similar. Ice cream, cake, and apple. So there is ice cream and cake. You choose, let's say, a population of people, choose each of them with some probability. So ice cream, cake, and then you add apple to it. So if you added apple, what do you think? Can probability of choosing ice cream go up or down? There were just apple, only down, right? There were just apple and cake. I keep forgetting. Ice cream and cake before. So maybe you chose it with 50% probability. You add apple. It's like adding competition, right? Suddenly it cannot go up. If it goes up, it violates some of the rationality axioms. That should not be obvious to you why, but you could derive that. But sometimes we see that. Sometimes we see that if you present things differently, people start behaving differently. If you come to a restaurant and there is a menu, what to order for lunch, sometimes if there is too many of dishes written on the list, you just say, oh, that's too many, I'm not gonna read it, and you pick the first one. Well, if there were 3, you would read it in detail, and you would not pick the first one. So we behave this way. And there is this example that also I want to go through that with you. So let's say there are 2 lotteries again. You can choose either you can choose that I give it 1,000 Czech crowns for sure, or we play a lottery. If you lose, you will get nothing. If you win, you get 1,500. Which one would you pick, A or B? A, right? If it's for sure and it's on average better, let's pick A. Then, what if it's slightly different? And it is that before I toss a coin, let's say the coin is, I toss it and I don't show it to you first. And you can then choose A or B. And I will tell you, now you can give me 500, if you give me 500 Czech crowns, I will first show it to you, and then you can pick A or B. You're nodding. Would you take it? You still wouldn't, because at most you would get minus 500 and 1,000. Still, that's not good, because you pay a penalty of 500. Still doesn't help. But imagine that I change the menu of offers. That I now add a 3rd offer. And that offer is that I give you 10,000 if one of the sides of the coin falls down, or I give you nothing. And I'm still giving you the option of paying 500. Just take C? That's one option, and for sure it's better than just take A. But what you can also, maybe I didn't select the numbers perfectly, but what you can also do is pay 500. And then if this one falls, I take B. If this one falls, I take C. And I think that if you dig deeper, you find out that that's even better. And for sure, I could find some numbers that would work out this way. So just by adding the 3rd option, probability of selecting B should go down. But it changes your way of thinking about the problem. That's like with the menu of dishes for lunch, that if you, well, there maybe it was too simple that there were many of them, you stopped thinking about it. Here you see that there can be something fairly obvious and nuanced, that it seems that the person is rational, but maybe not so. So then, ever since the 80s, for next 40 years, there was something, a growing field in economics called behavioral economics. Basically, it's like a combination or application of psychology to economics. And these behavioral economists kept showing economists like where they make mistakes. Now there is a huge list of results where we people make mistakes. And I don't know how about you, but I make mistakes all the time, every day, and so on. And those mistakes are of all different forms. Of course, they violate those four axioms, but sometimes that's not too constructive. They're different. So for instance, we have inconsistent preferences. Inconsistent preferences, that means that in different situations, I prefer one thing to the other or the opposite way. That's loss aversion. That's something that we talk about. It's related to self-control problems. Self-control problems, those are problems with, so for instance, with drugs. That's something that you cannot resist. You take it, and then later on, you regret. If everything was rational, we would never regret. Often this is related to, it's called impatience. So for instance, there are experiments where you ask people, Do you want $100 today or $110 tomorrow? That's 10% in one day. That's quite an investment, right? And still a lot of people say $100 today. 10% a day, that's a lot. But if you ask the same people, do you want $100 in a week or $110 in a week and a day? Suddenly they prefer waiting that extra day. That's also inconsistent in time, that from today to tomorrow, they're not willing to wait for $10, while from 7 days to 80 days, they are willing to. That's how we have our urges, we have chemistry inside. We're not always rational. Also, the way we work with uncertainty is often surprising. So, for instance, what about this example, this experiment? Imagine two boxes. They will be, or imagine they're sealed. And there are two types of balls. In one box, they're just red, well, you see there, red and black balls. And you know that there is the same number of black as well as red, 30 and 30. It's sealed. You can put your hand inside. If you pull something up, let's say I give you a bet. You can say which one you think. You will say, for instance, red. If you pick red, I give you $2. I should stop saying this because maybe it's recorded. Right? So that's a bet. That it's 50-50. There is 30 red balls and 30 black balls. But there is another box. There are some red balls, some black balls. You know there is 60 of them, but you don't know how many of which. And again, you can pick one of the colors. That's up to you. And then if you draw that color, I give you again the same amount. And I will tell you, which bet would you pick? Would you like to be drawing from the left box or from the right box? Which would you prefer? How many left? How many from the right? How many of you think there is no difference? There is no. Why do you think there is no difference? Exactly. You don't know, and since you can randomize 50-50 whether you choose red or blue, so imagine that even if you knew here that it is 20-80, but you didn't know whether it's black or red this. You randomize this, then it will be either 20-80 or 80-20. Average of that is 50-50. But we as people, typically in most experiments, people choose the first box. It's like known unknown is better for us than unknown unknown. Well, 50-50 in both cases. In the first case, it's like we know it is 50 balls versus 50 balls. In the other case, we don't know. Go ahead.
Yeah, but in the first case, I'm sure you're not biased toward a particular color. It could be 20-80, but I have no guarantee that it's 20-80 or 80-20. It could be a little bit more probable for the
Yes, you're exactly right if I wanted to trick you. But I gave you the option that you choose yourself whether you are betting on red or black.
Yeah, but I'm not sure if we are biased towards different colors. Like, I could like...
Sorry guys, I have to answer this. My son is calling. He's home alone and sick. I just make sure that... Ondro, všechno dobrý? Dobrý, ciao. Everything's okay. Yeah. So if I told you it has to be red, you wouldn't know. But if I'm giving you the option, you can choose whether you're betting on red or blue or black.
Yeah, but maybe I like red
Yeah. But what you could do, you could pick up a coin from your pocket and and that coin would tell you whether to bet on red or.
But isn't it easier if the coin is just the left box? The left box automatically.
That's a good explanation. So thinking is hurtful, right? So when you're doing physics Olympiads and competition here, is it fun? So you're saying it is. So for me, I loved it. I loved practicing, I loved it. But I remember when I was doing the competition, and like you're sitting somewhere for 4 hours, sometimes it is tiring. It is, and you guys love it. I loved it too, but some people don't like thinking. So it's true that in the first case, it's obvious that it's 50-50. In the second case, we have to think a bit more about it. And if thinking is costly, we can avoid it. Great? That comes again. So remember that once we have to think about something, maybe we behave differently. Axioms of rationality somehow assume that thinking is costless and we always get it for free, that we always decide perfectly. Now we have to depart from that a little bit. I'm going to skip mental accounting. By the way, so we stop at 30, right? Yeah. 3:30. Okay. Sometimes we simply make mistakes. We know that decisions take time. We make mistakes and so on. So this is all part of behavioral economics. Now, we know that we are not perfect. Evolution knows it too, but we know it not only like through history, but even at this moment. Actually, we know. Some of us do know it, some of us don't. You can, if you're not rational, or if we are not rational, we can still divide that behavior into two classes. Irrational and naive. That's someone who makes mistakes, but doesn't adapt to it. Somehow doesn't realize I make mistakes. It's someone who, I don't know, let me not come up with an example. Often, people are sophisticated and irrational. That means that we have our mistakes. Thinking is hard, but we are trying to adapt to it. We are trying to somehow do the best we can in life. So, for instance, we can consult friends. We can look at the internet. We can do other things. For instance, for self-control problems, sometimes if you have a choice on the menu from 3 things, it can be better just to a priori say, no, I'm going to be choosing only from 2. It's like with drugs. If we have self-control problems, maybe it's not the best idea to have a drug on the table at home all the time. Then the probability that we wouldn't resist is higher. We want to put it away. This is Odysseus. I don't know how to say his name in English, actually, but you probably understand what I mean. So with his crew, they went by an island with sirens. They were beautiful. They sang beautifully. He really wanted to see them and hear them, but he knew he could not resist. So he would jump, swim to their islands, and they would kill him. He knew that in advance. So what he did, he asked his crew to bind him to the mast. Sometimes we do this. So for instance, there is well-known result that some bank in Philippines offered a contract to people saying, if you sign this contract, then anytime you withdraw more money from your account in a month than, I don't know, $1,000, you will pay extra penalty. It sounds like a weird contract. Why would you sign it? You don't gain. They didn't give them anything for it. They didn't increase interest rate. They just said this. A lot of people signed it because it was good for them. It forced them to save more. Sometimes we do these things. So adaptation is crucial. I'm slowly getting to second part of what we're going to be talking about here. I want to talk a lot about information. You already said something about thinking. By the way, guys, I didn't say it before. Anytime there is something you'd like to talk about more and ask me, do so, please. I'm sorry that it's been such a monologue, but there'll be chances. So it's great that you're participating in this competition. Maybe you're also believing that it helps your CV, right? That it will be written in your resume somewhere. I could pose this as a question, but I'm writing it there already. So there is research that shows that on average, HR managers, meaning if you send a CV to a company applying for a job, on average, they spend 7 seconds looking at the CV. Not 5 minutes. They don't read in detail the essays that you send them. No, on average, they spend 7 seconds. So the decision is very crude, very coarse. Going back to economics, often in economics, we assume that anything that's happening, we people know about it. Central bank changes interest rates, immediately everyone knows about it. That's also not true. A lot of people don't even know what inflation and interest rates are. And there is evidence that on average, people know about macroeconomic conditions or get information about macroeconomic conditions about 3 bits a year. Do you know what a bit is? 1 bit? That's like 1 0 or 1. So that's like you learn 3 things. You can ask 3 questions to which there is yes or no answer. And that's it in a year. So in a year, you, for instance, find out that inflation went up and not down. You don't find out by how much, and that unemployment went up between something and something. I don't know. That's it. We know very little. The last one is striking. So often on the news you read how central bankers, the governor, chairman of the Federal Reserve System or European Central Bank, how much of experts they are. There is evidence that their behavior is strongly affected by what they experienced when they were young. So central bankers that experienced high inflation, when they were in their formative years, behave very differently than central bankers that experienced high unemployment, for instance. We are simple creatures, and central bankers are too. Now, when we are picking products, so this is offer of electricity plan. So you're consuming electricity at home and you would like to get it from providers the cheapest. Very often the offer looks like this. So this is check offer. A lot of numbers. They're trying to obfuscate it. Of course, when you have offer like this, it's difficult to compare 2 offers and say which one is cheaper. In the end, it's a linear scheme. It could be something like this, but that's not how it's presented. So in economics, information and thinking plays a huge deal. It affects all parts of economics. I'm going to talk about examples, don't worry. So far, we are somewhat technical, theoretical. It will get less so. So attention, that is like your capacity, how much information you can get. We know it's limited. We know certainly for central bankers and HR managers it's limited, but it's limited for all of us. So, I don't kid myself that you listen to every word I'm saying. So I'm showing pictures too. But it's up to us to choose where to allocate our attention. We pay attention to things that are more important for us. That's the adaptation. So that's the part of, I told you that economics started with this rational thing. Of course, it wasn't great. It had its flaws. We're not rational. But the big advantage of that was that it could study if a law changes, how our behavior changes. And that is crucial for economics, the changes. So in the end, we are asking, should taxes be higher or lower? Should market be designed differently? Behavioral economics often is more realistic in how we behave in a specific situation, what type of mistakes we make. But we don't have great understanding of if the situation changes, do do we make different mistakes? So it's good to somehow combine these two. How we adapt to the fact that our attention is limited. So that's a theory that my advisor, Chris Sims, back in grad school, started, and then I helped develop it, called rational inattention. And so that's sort of combines psychology, but just only a small piece of psychology. The notion that we cannot get all the information, that we have to pick. Only, let's say, we could start with the assumption we can get only 3 bits of information about microeconomics a year, but it's up to us what 3 bits it will be. So maybe a person from China will care about inflation in China, a person from the Czech Republic will care about something else, unemployment, I don't know, or some details. Adaptation, that's classical economics, and then the question is how to model it. And for that, we use information theory. I would guess that many of you never heard of that. It's something that is super useful. It's a beautiful theory, started in 1940s by Claude Shannon, and then it has a lot of connections to physics and also to biology. It's actually fairly simple and super deep and powerful. So, and something elegant, something that's easy to work with. So I would suggest that if you like such things, look into it. So how to model it? I remember in grad school in Princeton that I had discussions with philosophers. They were saying, information is something that you can only talk about qualitatively, that it's not something that you can describe, model. That's not true. So in math, physics, everywhere, information is something that for the last 100 years we sort of know how to describe. And that is, you first describe what you know. You're probably thinking that I look quite confused here. I'm thinking how to draw something. So here I'm writing inflation. Let me give example with temperature. So now you could be thinking about how warm is it outside? So there will be temperature in centigrades. Let's say here it would be 10, 0, 20, and you have some idea, and that idea can be described by a probability distribution. So here, this would be my belief that, you know, I was there an hour ago, it was about 8, I don't quite know. It could have changed within that hour, so maybe there is some probability that it's freezing outside. Probably not, but, you know, some probability. And also some probability it's above 20. But most likely, my guess would be it's here. That's how you describe, we call it beliefs or knowledge, what you know. Information is that you get a signal, you observe something. So for instance, when I started thinking about it, I looked outside. I don't see sunshine. Maybe I could see a person, how they're dressed. It gives me some information. And that information can be described by that then my knowledge will be more narrow. Does it make sense? So first I didn't know whether it's between -10 and 30, and now I'm more sure that it's in this narrow range. And information is the reduction of uncertainty. That's how it is modeled. So for many decisions, we need to simplify the world. We create models in our head. Information is also just some low-dimensional feature of the world and so on. This is Picasso's drawing of a bull. He simplified the bull. He started with the bull on the left and then kept simplifying all the way to this one. He said those are the most important features of a bull. It's much simpler. You look at it and you might still guess that it's a bull. Much simpler. Why I'm talking about it is that this is not the only possible simplification of a bull. Like if you said, what are the main pieces of information to transfer about a bull? Someone else maybe cares about completely different things. Like I was saying, the example of a person from China and Czech Republic. Or a rich person in the Czech Republic cares about very different things than a poor person in the Czech Republic. So maybe a butcher would simplify a bull like this. Maybe that person doesn't care about shapes, but cares about different types of meat. So let's get back to how we model how to pay attention. So we already talked about it, some maximization problem. If X, the state of the world, so for instance, temperature or inflation is uncertain, you have to start working with probabilities and averages, so you would solve such a problem. This is integral, that means it's some average over probabilities. I think I'm gonna skip this. So the model I'm getting to is that imagine that it will be some optimization procedure, that there is something you know, and then the person is thinking about where to narrow it down the most. And that models what type of information the person gets. And then with different types of information, they're differently happy. So maybe if they learn a lot about their spouse potential, that's more important for them than learning about inflation in China. In the end, the model looks something like this. So you see some optimization procedure here, you see some constraints, and also this piece is important, there is a cost. And the cost is, you have this big uncertainty. If you narrow it down, you need to get information. And you get information by talking to people, by reading. It takes time, and time is costly. So the more you narrow it down, the more you have to pay for it. And that's where information theory comes in. That cost can be described by, it's called reduction of entropy, entropy of the distribution. You probably heard of that in physics. I'm not gonna go in detail, but information theory is a beautiful theory here that it actually shows that this is very useful. Any questions?
At the beginning, you told us about you asked us if we choose the bet with 1,000 pounds and 2,000 pounds, and you said that of course if it's $1 million, 1 million pounds, then you wouldn't the first option. Where is the limit between 1,000 and 1 million on average, where people say that no, this is my limit, I'm not talking about.
Oh, that's a great question. So it's different for different people. I will draw something. Oh, it's drawn here actually. Utility function of, maybe it makes us happy of how much we have. This is wealth. Typically, it is assumed that it is increasing and concave. Concave, increasing means that the more money we have, the happier we are, or like the better things we can buy and so on. But concave means that if you add $10 here, suddenly you're not starving and you can buy a sandwich today. And if you already have $1 million, those additional $10 doesn't make you as happy. Right? So that's why it's concave. So imagine a person, I should have drawn it slightly differently. I'll draw it very concave. Look at this. So if I'm here, if I take very small things, minus $1 plus $2, and let's say this is on the order of 1 million, then it will always seem like linear. That going one step down will always be, like if I have a choice of going one step down and with 50% probability 2 steps up, if I average these two, they will be higher than this. Because here it's pretty much linear. Only the difference is that for gains, I go twice as far. But if I suddenly make the steps bigger, see that here maybe I go 2 steps, and here I go 1 step down. This loss can be larger than gain for 2 steps up. So it depends on how concave it is. The richer you are, the more linear it is. So for very rich people, it doesn't matter whether it is plus minus 1,000 or plus minus 1 million. For very poor people, it will matter a lot. And also, people differ. Some people are called more risk-averse. There is evidence that older people are risk-averse, that, that if they lost something, or in general, just thinking about, I don't know whether it will go up or down. Older people would be more risk-averse, while younger people would say, what the heck, let me just try it, it will be fun. So there is a lot of research on actually studying your question. So I can just say people differ and situations differ. Typically, if you're richer, the threshold would be higher. If you're younger, the threshold would be higher, and so on. Not always. Does it sort of? So, thanks for the question. Any more questions? So I'll give you a few examples where I show you this modeling of limited attention matters a lot. I'll show you a few projects that we did. So this is a project on discrimination. This is a picture of how it looks like in colleges when they're looking at applications, which students to admit to university and which not. There is many of them. On job market, it works similarly. There was this beautiful experiment. So you can imagine that it's difficult to measure discrimination, right? So you see that maybe females have lower wages. You see that maybe in the US, African Americans have higher unemployment and so on. The question is, what is it? Is it because of skills, discrimination, and so on? So there was this experiment that they sent fictitious CVs. So imagine they took a CV where they wrote Emily something something, or Greg, I don't know, Greg Biden, this college, 22 years, and so on, and send it to 500 firms saying, I'm applying for a job at your firm. They then took exactly the same CV, and the only thing they changed was the name, Jamal something. Send it to 500 firms. I suddenly saw that Jamal was invited to interviews with 50% lower probability than Greg. The reason is Jamal is much more African-American name in the US than Greg. We did something similar in the Czech Republic where we used Czech names, Vietnamese names, and Roma names, and again, twice as many of the Czech names were invited to the interview. CV was exactly the same experience, the same education, the same place of birth, and so on. The link to inattention is that what we also did was that in the email was, and you can find my CV on this link. When there was a Vietnamese, Roma, or African-American name, 50% less of people clicked on the link. They didn't even read the CV. So you saw before that on average, HR managers pay attention to CV for 7 seconds. Sometimes they don't read it at all. So limited attention plays a huge role in discrimination and unemployment and so on. And if you know that it can be also because of this, then you can start thinking, okay, what would help? Quotas, or now a popular thing is, it's called name-blind resume. That is that in the first stage, when HR manager looks at it, they don't see name and sex. So they just see education and so on. So they cannot discriminate based on those things. I'm going to skip this. This is something that I think is important. I like skiing. Can imagine many of you do too. There is a ski lift right here, Portážky in Czech mountains. What's beautiful is that right here, 20 meters away from there, there's a ski rental. Maybe you don't appreciate it, but from some other perspective, it's like magic. You go to mountains, you want to ski, and at the best place where you would like it to be, there is a ski rental. And it has the skis that somehow make sense, not those made of gold or something 50 years old. There's something that there is a good trade-off between value and price. But you didn't have to think about it. Someone else did. Somehow it happens automatically through free markets. In meat stores, it looks similar. This is a meat store next to us, close to where I live. Seems like there is typically things that I would look for. Then also they pair it with drinks that I would look for. But it wasn't always like this. In the 80s, it looked like this. You would come to a meat store, to butchers, there would be maybe one sort of product. And that's it. The main difference is that one is run by free markets, the other by centralization. There is one minister, central government, that thinks about, what should they have in this butcher store in the center of Prague? Central government has some advantages. We also know that free markets have some advantages. Often we say it's motivation, because if it's free market, you work harder and so on. But what we forget about, or what's not so known, is that information matters a great deal. Imagine there is a government. We used to have communist government. There would be a minister, one guy thinking about those things. Very difficult to do. Well, if it's the free market and it's the owner of the shop himself thinking about, what do people on my street like? He gets much more information about his specific local situation. So information matters a great deal if you're thinking about how the whole economies and how government should be structured. So I guess I should stop within 3-4 minutes, right?
We can go like 5 minutes more.
No, I'm fine. So I'm gonna skip this example. If you want to ask me about it later, how inattention and politics works, I will return to it. By the way, the first lecture that I saw in Princeton was by a Nobel Prize winner in physics, actually. I forget which one. And I remember he went 2 minutes long and said, 2 minutes destroys every good lecture. So I hope I'm not gonna do that. So I'm gonna skip it. Anyway, so information is super important for all types of markets and interactions. You know, we already talked about discrimination, about politics, right? You know that we don't pay attention to details, different candidates. We don't read the whole platforms. So it's often like the first opinion matters a lot. Trump is now super successful for good or worse, super successful in terms of getting voters. He's a master of grabbing attention. Makes a huge deal. On marriage market, it's very important, and so on. Financial markets, portfolio diversification, super important, what you pay attention to, and so on. So I'm just gonna stop with 2 quotes. So this is Milton Friedman. He's one of the big guys of our profession. Most of his work was done in the 70s. He basically believed that, you can read the quote, but he believed that free markets are the way to go, and there are like no exceptions, almost. By now we know that there are a lot of exceptions. He was a great man, but it's a long time ago. He certainly didn't know everything. So we know that sometimes markets fail, we make mistakes, and so on. So governments can be useful in some things, but not in everything. Okay, another great guy in your profession. He wrote a curious article in 1949 saying why socialism is the way to go. He had some good arguments for it. That sometimes we just are too greedy and so on, that education is important, but his main argument was that it can be done, that planned economy can be done. In theory it can. In practice we know that as humans, we just are not able to get the information. Maybe later on with artificial intelligence, who knows, but still it will be difficult to get to our head and get information from there. So there were some practical things that he just didn't understand, and why should he? He did wonderful things elsewhere. I'm showing it that this is how I want to conclude. Economics, it's a field, if some of you will consider it in the future, it's a field I love. So I always liked physics and compute things. Now I'm using the same methods to solve problems that I care about. I would also care about solid state physics. Maybe I wasn't good enough for that, but now I care a lot about unemployment, discrimination, democracy. Similar methods can be used, but the world is very complicated. We use mathematics, just like in physics, but mathematics in a way to structure discussion and make the discussion more transparent. Just like I showed you the axiom that first, let's agree on what we call rationality. Then we can go from there, we can model and so on. In economics, more than in other fields, of course, we will never write the model correctly. People are more complicated than single atoms and so on because we're made up of many atoms. But we have to keep combining theory and data back and forth, just like Einstein had a beautiful intuition and theory in physics. He had great intuition in economics, but there in the end the intuition failed with socialism. Right? So we have to go back and forth, theory and data. That's what's similar to other fields. That's it, guys. So I did go 2 minutes late. But anything you'd like to talk about? Sure.
I will probably give you this, so it's a recorded question.
Since you showed Milton Friedman, he was a famous monetarist. What's your opinion on Javier Milei's plan to dollarize Argentinian economy?
Oh, that was too good.
Answer, please, in 10 seconds.
Sorry, I still have to grasp the question. So, to how the current president wants to dollarize the economy? Yeah. I think there is, I don't know in what deep, and I'm trying to look for words that's more formal than deep shit they are in. If they have big problems with self-control, so I don't think there are answers in traditional monetary theory that can answer that. It has advantages and disadvantages. It's similar to like whether we should have euro or not. I think big advantage is that if they have major problems with self-control within, like if they would know what to do, but in the end they would always spend more money because of political reasons and be corrupt, dollarization, just like euro, is something that would tie their hands. So saying I'm gonna dollarize in the future, it can actually be a good strategy to force them now to do reasonable things. But I don't know details of the, yeah. Thank you. Any questions? No. Thanks a lot, guys, and great that you're doing these things, and good luck for the competition. And enjoy Prague, that's also important.
Okay, thank you again for the lecture.